Welcome back to my YouTube channel. My name is Mohammed Ubaid and this is another video of basics of structural analysis series. In our previous video, we have started a new topic which is conjugate beam method. In this video, we are going to solve a numerical problem based on that method. So let us see what is that problem. So here you can see that we have a cantilever beam which is subjected to a point load of 100 kN at the free end C. This beam is having varying cross section, which means that the segment BC has a moment of inertia I and segment AB has a moment of inertia 2I. In this problem, we are going to find out the slope and deflection at this point B and slope and deflection at the point C by using conjugate beam method. If you are new to our channel, please subscribe to our channel. If you find this video helpful, please like and share this video. If you have any confusion regarding any point in this problem, please comment down in the comment box and I will try to answer all your comments as soon as possible. Without any further delay, let us get started with the solution of this problem. So this is our problem. Okay, now let us call this beam as our real beam. Now we have to change this real beam into its conjugate beam. So how we are going to do that? So first of all, we will change the support condition. Okay, so let me draw the beam here again. This is our conjugate beam. Okay, so let me draw the beam only. Okay, not its support condition. So this is A and this is B and this is C. So as we have discussed in our previous video how we change the support condition, if you want to understand all those things, you have to watch that video first, then you can understand all these things very clearly. So you will find the link in the description box. Now this is our fixed support at A. So this fixed support will be a free end in conjugate. Okay, and at C we have a free end. So in conjugate beam it will be a fixed support like this. Okay, so this is how we change the support conditions. Now what will be the loading on this conjugate beam? That is very important. So to find out the loading on that conjugate beam, we have to draw the M by EI diagram for the real beam. Okay, for the real beam. So to draw the M by EI diagram, we have to draw the bending moment diagram. So for drawing the bending moment diagram, we will find out the bending moment. So bending moment at C will be 0 because it is free, and bending moment at B will be minus 100 into 2. It will be minus 200 kilonewton meter, and bending moment at A will be minus 100 into 4. Okay, because the distance between C to A is 4 meters, so it will be minus 400 kilonewton meter. Now let me draw the bending moment diagram, which is very easy to draw. So it will be a triangle. Okay, like this, and this is B, this is C, this is A. At B we have bending moment of 200 kilonewton meter. At C we have bending moment 400 kilonewton meter. Okay, and the diagram will be negative because all these two moments are hugging moment. Now this is our M diagram. Okay, M diagram, or you can say that bending moment diagram. Now we have to convert this M diagram to its to the M by EI diagram. So what we will do? We will divide this M diagram by the value of EI for the segment of the beam. So we are assuming that the EI is constant, that the value of the value of E is constant, not I, because I is varying. So the value of E is constant. Okay, so the only variable is I. So for that segment AB, the value of I is 2I. So all these values of moments like 400 and all the value which will come between A to B will get half. Okay, so let me just draw the reference line. So this is our A, this is B, this is C. Okay, so this is 4. So when I will divide this 400 by the value of this 2I, okay, which means 2EI, because E is constant, so it will be 200. Okay, so this will be 200. So let me draw here. So it will be 200 by EI, and at B there will be discontinuity because in segment AB we have moment of inertia 2I, and in segment BC we have moment of inertia I. Okay, so it this 200 will get reduced to 100. Okay, like this, and for that segment BC it will remain 200 like this. So the diagram will be like this. so it will be 200 by EI, and here this point, so this point, let me write it here, so this point will be 100 by EI, okay, and it will be negative. Now let me uh, let me let me repeat this again. What I have done, I have divided the bending moment or bending moment diagram ordinates by the value of moment of inertia of that segment, okay. So when we divide 400 by 2i, 400 by 2ei, so it will be 200 by ei. When we divide this 200 by 2ei, so it will be 100 by ei. And for the segment BC, the value of I is I, so it will not affect our bending moment diagram for the segment BC. Okay. Now this is our M by EI diagram. Okay. So in our previous video, we have seen that this M by EI diagram will be applied as the loading in our conjugate beam. Okay, in our conjugate beam. And one important thing which we have discussed there, that if the bending moment diagram is negative, okay, if the bending moment diagram in the real beam is negative, the loading on that conjugate beam will be applied in the downward direction. So let me just draw here so that you can understand in a better way. So this is our first coordinate, sorry, this is 100, and this is again 200. So this is the diagram is like this. So this is like this. So this is our 200 divided by EI, and this is our 200 divided by EI, and this point is our 100 divided by EI. Okay. So as I have told you here, that the bending moment is negative, which means that in conjugate beam, this bending moment will be applied as a downward load. Okay, like this. So this will be applied as a downward acting loading in our conjugate beam. Now in the question, it is given that we have to find out the slope and deflection at B, and we have to find out the slope and deflection at C. So in our previous video, we have discussed in a very clear manner that if we want to find out the slope at a point in real beam, then we have to find out the shear force in the conjugate beam. Okay. And if you want to find out the deflection in real beam, then we have to find out the bending moment in the conjugate beam at that particular point. Okay, so we have changed our real beam into its conjugate beam. Now we will see how we are going to find out the slope at B, deflection at B, slope at C, and deflection at C by using this conjugate beam methods. So this is the conjugate beam which we have drawn, okay, from the real beam. Now as I have told you earlier that in real beam, if we have to find out the slope, then in conjugate beam we have to find out the shear. If in real beam, if you want to find out reflection, then in conjugate beam we have to find out the bending moment in the conjugate beam. So these two are for conjugate beam, okay, and these two are for our real case. Okay, now in question it is asked to find out the deflection and slope at B and deflection and slope at C. So let us first find out the slope and deflection at B. Okay, so for slope at B, we have to find out the shear force. You can also write it as let me just erase this. So slope at B in real beam is equal to shear at B in conjugate beam. Okay, so what is the value of you can SF at SF means shear force at B. Okay, so the value of shear force at B we can find out from this diagram very easily. So we have to consider the area of the loading diagram. Okay, so this is the trapezoid. So AB, and these two are the coordinates of this trapezoid. So the area will be 1 by 2 because it is acting downward, so it will be taken as negative. So 200 divided by EI plus 100 divided by EI, okay, and multiply by the length of the segment AB. So this is also 2 meter. Okay, so from here this 2 and this 2 will be cancelled out, so it will be minus 300 divided by ei. Okay, so this is the shear force in our conjugate beams, and this shear force is equal to the slope in our real beam. Okay, so the value of slope means theta b is 300 divided by ei. Now what is the direction of that slope we will see later. uh, right now we are just finding out the values. Okay, now what will be the deflection at the point b? So for deflection at, sorry, it is for deflection at b in real beam, we have to find out the bending moment at b in its conjugate beam. Okay, so from this diagram, what will be the bending moment at b in conjugate beam? So the bending moment will be the area of this loading multiplied by the distance of the CG of this loading from B. So we can write 1 by 2, 200 divided by EI plus 100 divided by EI into 2. So what is this? This is the area of this trapezoid. Okay, AB, and 100 by EI and 200 by EI. Okay, now the distance of the CG of this trapezoid from B, because we are finding out the bending moment about B, about this point. Okay, so this will be the distance. Okay, this will be the distance of CG. Now for trapezoid we have a direct formula. Okay, so the direct formula is 100 plus 2 times 200 divided by 100 plus 200 multiply by 2 by 3. What is 2 by 3? So 2 is the length of the segment, length of this segment AB. Okay, so this is our 2 and 3 is in the formula. Okay, now from here we can write down the value of this slope. Oh, sorry, this is our bending moment at B. Okay, so it will be minus triple three divided by EI. Okay, so as I have written here, that deflection at B in real beam is equal to bending moment at B in conjugate beam. Okay, so we can write here that the deflection at B is equal to minus 333.33 divided by EI in real beam. Okay, now we will discuss the sign conventions and the signs later. Now we have found out the deflection at B and deflection slope at B. Now we will find out the slope and deflection at point C in real beam. Okay, so let me write it here. Slope at C in real beam. RB means real beam. Okay, so for finding slope in at C in real beam, we have to find out the shear force at C in conjugate beam. Okay, so for finding out the shear force, we have to consider the whole area of this loading. Okay, whole area of this loading. So first of all we have this trapezoid and then we have this triangle. Okay, so it is very easy to find out the area. The area of the trapezoid will be minus 1 by 2. So the ordinate, first ordinate is 200 divided by EI. The second ordinate is 100 divided by EI, and the length of the segment AB is 2 meters. Okay, the other one is minus 1 by 2, sorry, 1 by 2 into 200 by EI into 2. Okay, so here you can see that this is if we want to find out the area of this triangle, it is 200 and the length is 2 meter. Okay, that's why I have written here is 1 by 2 into ordinate. Okay, sorry, let me write it again. So it is 200 by EI into 2. Okay, now after solving we will get the value of this as minus 500 by EI. Okay, so this shear force in conjugate beam at C will be equal to slope in real beam at C. Okay, So this is how we can find out the slope at C. Now for deflection at C in real beam, we have to find out the bending moment at C in conjugate beam. Okay, so the bending moment, how we are going to find out the bending moment? So let me write it here. Bending moment at C in conjugate beam. Okay, so we have two areas. Okay, the first is for this trapezoid and the other one is for this triangle. So we have to find out the bending moment of these two areas about of these two loading about this point C. Okay, so we can do it in the similar way as we have done here. Okay, for the bending moment at point B. Okay, so first of all we will consider trapezoid. So the area is 1 by 2 times 200 divided by EI plus 100 divided by EI multiply by 2. Okay, so this is the area. Now the distance of CG. So the distance of CG will be 100 plus 2 into 200 divided by 100 plus 200 into 2 by 3. So this value is the distance of CG of this trapezoid from B. Okay, from B. Be careful as we have done here. Okay, so this is the value of centroid of this trapezoid from B, but we are finding out the bending moment about C. So we have to add 2 meters in this value. Okay, we have to add 2 meters in this value. So this is the bracket. So let me add 2 meters. So this is the total bending moment of this trapezoid. Okay, now the other one is for the triangle portion. Okay, so for this triangle, so it is very easy to consider the bending moment due to this triangle. So it will be minus 1 by 2 into 200 the ordinate into 2 into distance of CG. So distance of CG will be 2 by 3 into 2. Okay, so after calculating, you will find out the value of bending moment at C in conjugate beam will come out to be equal to minus 1200 divided by EI. Okay, so this bending moment at C in conjugate beam is our deflection at C in our real beam. Okay, so in this way we can find out the slope and deflection at all these points. Now let us understand what is the significance of these signs. Okay, so in our previous video we have discussed the sign convention. So let me just open that slide for better understanding. So here you can see that if we get a positive value of shear force in our conjugate beam, which means that the slope is anti-clockwise in the real beam, and if we get a negative value of shear force in conjugate beam, it means that the slope is clockwise in the real beam. Now let us see what we have got in our problem. Okay, so this is the so this is the shear force. So we have got a negative shear force. Okay, so which means that the slope is you can write it as here that the slope is clockwise. Okay, sorry, let me we don't need to put a sign here. Okay, we can just write it like this. Okay, the slope is clockwise. Okay, and here also the value of shear force is coming out to be negative, which means that let me raise this sign and put the direction. Okay, you can also show the direction like this. So this is our clockwise. Okay, so let me write the value here, this sign 500 divided by EI. Now this is about shear force. Okay, now let us see what is the sign convention for bending moments. Okay, so let me go to that slide. So if we get a positive value of bending moment in conjugate beam, which means that the deflection is upward, and if we get a negative value of bending moment in conjugate beam, which means that the deflection is downward in the real beam. Okay, so let us see what we got in our case. Okay, so for point B, we have got a negative value. Okay, we have got a negative value of bending moment, which means that the deflection is, you can write it that the deflection is downward. Okay, and you can write the value here with sign. Okay, with sign for your better understanding, 333.33 divided by EI. Okay, because if you are showing the direction, it doesn't mean we don't need any sign here. Okay, and also for point C we have got a negative value of bending moment, so we can just show the sign here like this. So show the direction. Okay, direction means downward. Okay, because we are getting a value of negative. So this is it. How we can find out the slope and deflection in a conjugate beam by in a beam by using conjugate beam method. So this is it for this video. We will meet in our next video. Thanks for watching.